Also this project, no rocket science. But it's a very handy device, and I already created this a long time ago for my living room and my garden, and I'm still happy with it. And now I had a need for one in my office. I'm quite sure you can buy those kind of devices off the shelf, but I wanted one that I can include in my home assistant, so that I have nice buttons on the dashboard to control what I want. Let me explain with one simple picture what it is and why it also can be handy for you. So this is a visual of my office. I have my work desk here and I have a set of speakers on the side. A while ago I installed a big screen on that wall together with a pair of speakers. And I'm using it a lot for previews or to show people something. But from the moment that I connected those speakers, those were not active anymore because I had only one pair connected. So when I'm doing video editing now, my work location is here and the sound is coming from those speakers, which is not that convenient. So I thought, let's use exactly the same concept as a while ago for my living room and the garden and have a speaker set A and a speaker set B and make a simple device that I can control from my home assistant dashboard to select the speakers that I want to use for the sound at that moment. Because it's working for years for the house and the garden, for me it's a proven concept that I can simply rebuild for my office. And because I need to build this one from scratch, I thought let's create guidance videos about it. Let me know if this is also useful for you. Let's do a quick run through the components in this project. Of course, we have our ESP8266. We have a 4-channel switchboard, an empty PCB that I will use to connect everything on. I'm using a 5-volt power supply that I had laying around. One male DC power connector. A handful of terminals that I will connect the speaker wires with, and some cable, 0.5 millimeter. These are some of the tools that I really like to use. This is my TS101 soldering device. A small screwdriver for the terminals and the switchboard, a small wire cutter, and this one that I will strip the cables with so that I can connect them. That's it, let's start. For this video I assume you have some knowledge about ESP Home, the add-on in Home Assistant. If you are already a bit familiar with that, it's easier to understand why I first do the basic config and later I'll update it with the definite config. If you're not yet familiar with ESP Home, don't worry, but the coming things can look a little bit complicated. If you're lost, do one step back in the video or do a side step and search for some knowledge about ESP Home Builder. There is a lot of information to find and it will be really helpful for not only this project but also for a lot of other things. As for now, I'll configure the ESP8266 in the way that works for me. First with a basic configuration and then verify that it comes online, before flashing it with the final code. So let's quickly create a basic configuration. New device, continue, we'll give it the name speaker switchboard. Next, we'll choose the ESP8266 that I'm using. We leave the encryption key for what it is and we do install. Here we can choose from some options. I'll choose manual download. When the file is ready, I'll flash it to the ESP with PowerShell. The file is ready. I'll save it as speakerswitchboard.bin. You can also do the flash via Wi-Fi, but I prefer to do this via PowerShell. PowerShell is the standard available tool in Windows. If you use that, make sure you run it as an administrator. If you didn't run ESP tool before, big chance there is no Python on your system. If it gives that error, then you need to install Python. I will add a link in the comments how you will install that. For now, I assume you have Python installed on your system and you can do an ESP flash via Python on your PowerShell. I will also use the comment that I used for the flash in the notes. Keep in mind that it is different for you. You can have a different COM port and of course the file name. I used this comment before, so it's in the memory. I will simply use it again. The flash is done and now we should be able to see it in our ESP Home Builder in Home Assistant. The speaker switchboard is now online and we can simply update the code with the relevant entries to control the switchboard. This is the basic configuration that we will update, but now we know that the ESP is working fine. Here we have the speaker switchboard. I updated the configuration file and now I will download it to flash it on the ESP. It takes longer than with the basic version because there is more to compile. And there it is, it's ready. I will save it with the same name. I'll just override it so I can do a simple new flash. The flash is running again. And let's see if the device is up on the Wi-Fi that we gave it. And the device is up, so everything should be good to go to connect it. So the flash was successful and we're good to go to connect everything. I made a technical drawing of all the connections. I will publish the diagram on my website so that you can simply follow that as well. I prepared the PCB with the ESP8266 on it and the terminal connectors. Those connectors will stay empty until the last step that we connect the speakers and the receiver. Because we use a 4-channel switchboard, we can make this quite a simple setup. We will use one relay per speaker. I will make the connections between those two boards so that we can firmly fit it into a box. At the end we can simply place the box wherever we want and connect the speakers and the receiver. If you're familiar with those builds, you can take the wiring diagram and just start soldering. Otherwise, join me. I'll guide you step by step through the soldering. But first, let me give you some explanation based on the PCB. We have the two terminals that go to the receiver, like the left speaker and the right speaker. Here we have the two speaker sets, speaker set A and speaker set B. I'll give the example for one of the two speakers to keep it as simple as possible. For the other speaker, it's exactly the same concept. So we have the left speaker output from the receiver, and we have a left speaker in set A and a left speaker in set B. We will connect the negative wire from the receiver, from the left speaker, to both of the left speakers in both sets. And we will have the positive speaker wire from the receiver via the relay to the left speaker positive wire in set A and to the left speaker positive wire in set B. So two relays are used now. I'm using this concept in more installations in the house, not only in my office. And in this way you can turn on speaker set A and B at the same time, or choose for only speaker set A or only B. In my office, that's what I want to achieve. Only speaker set A or only speaker set B. But for my other setups, example in the living room and the garden, I want to be able to turn on both of the speaker sets. If you want to do that, always keep in mind your own technical specifications of your receiver and your speakers. So look at the resistance and check if it's possible to have two speaker sets running at the same time on your receiver. For me, this is in line with the specifications and it works good. Let's do some wiring. To prevent mistakes, I'll write some marks on the terminals and on the board. To make it dummy proof, you can also use some colors, like on the speaker wires, and I like to do that. To prevent that the parts are falling apart from the board when I'm lifting it, I already tagged some of them. And although I'm doing this more often, my soldering skills can use some improvement. And I'm using long enough wires here so that I have some flexibility. Afterwards I will use a box that is big enough so that it is not a struggle to fit everything in. Let's connect the switchboard, and I'll also make marks on this so that it is crystal clear what is what. We have the 4 relays and we have 2 speaker sets. So I will mark them speaker set A, left speaker, speaker set A, right speaker, speaker set B, left speaker, and speaker set B, right speaker. Here I'm connecting the wires with the connectors to connect the GPIOs of the ESP to the relay board. We use one GPIO pin for every relay. On the wiring diagram you see exactly which pins that we use and what will go to which pin of the relay board. The connectors of those GPIO pins go to the pins on the relay board. We use one additional ground cable to connect all the grounds together, so the ground of the ESP and the ground of the switchboard. And we connect the positive power wire and the ground wire to the DC power plug. I like to work in a structured way to detect mistakes in an early stage. Now we have wired the ESP and the relay board, we can do some first testing without speakers connected. If we go to the device, it shows the controls that it exposes. Here we see speaker set A left, A right, B left and B right. By pressing the buttons manually, we see that the relay is switching. That means that it's working and we can move to the automation part. Let's create the helpers for the speaker selection. We will create one helper for every speaker set. Here we have the two helpers. They are from the type input boolean of a speaker set A and B. Toggle switches. After creating the helpers, we move to the automation part. I already created the automation, but I will guide you through exactly what is there. From the graphical interface, it looks like this. When one of the helpers changes, it has some options. If the speaker selection is set on A, it will turn on those switches on the relay, and the opposite for when it's off. And for speaker set B, of course, the same. This is the automation in general. I will share this code on the website so that you can easily make use of it. Now let's see if it works. I added the speaker selection on the test dashboard of Home Assistant. Depending on how you configured it, the lights are on when the relay is off. If you don't find that clear, you can configure otherwise, of course, but I will just proceed with this. This is changing two of the relays, and this is changing the other two relays. So it does exactly what it should do. Now let's connect the terminals for the speaker and the receiver wires to the switchboard. I prefer to rewire things when there is no power on. So if something shortcuts, nothing breaks. Let's make sure we exactly understand how the relay works. According to the lights, the relays are now on. My multimeter is giving a beep if there is no resistance, so if there is a connection. And I'm testing the resistance between the left and the middle terminal of the relay. I'll now turn on my speaker set A, and it means that the lights should go out. The beep indicates that there is a connection. So we use those two terminals if we want to have the speakers on in the way that I configured it in my automation now. We will connect the positive wire of the left speaker from the receiver on this terminal and on this terminal. And we will connect the positive wire of the right speaker of the receiver to the middle terminal of speaker set A and the middle terminal of speaker set B for the right speaker. In that way we can turn on the right speaker of set A and or the right speaker of set B. The same for speaker set A, of course. I disconnected everything and will do the wiring. Those were the input terminals. Now let's connect the output terminals that go to the speakers. So the terminal for the left speaker A goes to the relay of the left speaker of A. Before putting this all in a box, let's do some final testing. If everything is working as expected, the ground of the left speaker from the receiver should always be connected to both of the left speakers. This is the ground of the left speaker, and we have a ground here. That works. And we have a ground here. That works. So the left speaker's ground is always connected to the left speaker's ground of the receiver. It should also be like this for the right speaker. Negative wire of the receiver's right speaker to the negative wire of speaker set A and the negative wire of speaker set B. That works. At this moment both of the speaker sets are turned off. So we should have no connection between the positive terminal and any of the speakers. Now let's turn on speaker set A. And we have a connection there. Let's test for speaker set B. And we have a connection there as well. To prevent surprises later, I'll just do a full test of everything before I put it in the box. Everything works fine. Now we can put it in a box and mount it wherever we want. For small electronics projects like this, I like to use those kind of boxes. They protect the board against some dust and make the whole setup a bit more rigid. There are small sockets on the side that you can break out and run the cables through. I just mounted the box under my desk and connected all the speaker wires. I'm now able to control both of the speaker sets in my office individually and I'm really happy with that. Let's do a short evaluation of this project and I'll run through all the costs of the components. I'll give you an overview of the costs of this project. I can already say the costs are neglectable for the benefits that this device will give you. It all starts with an ESP, of course. I'm using the ESP8266, they are about €3. I think that the most expensive component in this project is the relay board. I bought it for €7 on Amazon. For this project I used a 5-volt power adapter that I had laying around. But I guess if you need to buy this, it will be about €5 or €7 as well. Then there is a handful of small components, like the terminal adapters, the empty PCB, some wire and the box to put it all in. So let's say that the rest of the costs will be about €5. In general, that's about €20. And I think it's way less. I just did a search on Amazon to see if I can find those kind of devices off the shelf and what they cost. I found some of like €25 till €80, depending on, I think, the quality. Of course, there is something to say about the quality of the device I've built. But for me, this is about the functionality and not the real audio quality. Because it are not high-end speakers that I have. Also not a high-end receiver. Okay, it took some time to build it, but that's also the nice part of those things. I hope that I inspired you with this and that it is also a handy device for your setup. If you like those kind of do-it-yourself projects, then of course like the video. But also take a look at the other videos of my projects. There's a lot more to discover and there is a lot more to come because I just started with this. Enjoy building your own speaker selector. If you have questions, drop them in the comments and I'll try to help you. It's crappy footage and it's a mess in my office. But I can show you in real life how awesome this works. That's my screen with some nice ambient sound on the speakers in the corners. And if I want to have the sound on my desk, I can simply switch to here. And now I have those speakers. It's so convenient to switch on the fly what speaker set that you want to use. So I really like this device. Definitely looking at the cost that you can build it for. And maybe somebody knows that a speaker set selector that you can integrate in Home Assistant can already be bought. Otherwise, let me know if you're interested in this. If more people want it, I can investigate the possibilities of upscaling the production of this device. For me, this device beats all the alternatives that are currently available. Because a lot of those things just start with this, creating it, and then afterwards other people want to make use of it as well, but they don't want to build it by themselves. So let me know if you're interested in that. As for now, thank you for watching. This was Forest Guy Builds. I'm John. And I hope to see you in one of my next projects.